Now the data are n, x1 and y1, and these are the data here that you have to see that you have to fit. So let's first understand by making a program. So what I will do, I will make a program here where you can see that the we have to declare implicit none. An integer is n, and also let us take another integer I. Now you have to declare this x, y because they have several values up to n. So what you have to declare here in the beginning, you know that the declaration is always in the beginning of the program. So these are integer n, integer I, and you could write integer n comma I also. So real x and y, here it says that the x can take the maximum value to be 100. And suppose the data should not go beyond 100. So depending on, so safe is you can declare 200, 500, but don't declare like so many. So what you have to do that when you declare this here, so you have to just see that separate by comma. So it gives you the dimension, upper limit that the value can store. Let us define sum x, sum y, sum of the x values, all s, sum y, and sum x multiplicated value and x square values. M also let us take real and C also. So real x bar, let us initialize all the value starting with as 0. So, and file can be written open, unit is equal to 10, file is equal to pts.dat, and comma status unknown. Briefly I have written here. So status unknown, or you can put old because that's the data file. So what is that you have opened the file. Now in the file you have to make the data something like here. The file should be something like this, where first data is n and then corresponding values are x, y. So type this value and y. So x is, for example, let us take that there are 10 data. So x blank corresponding y1 value and x2 corresponding y2 values and so on. So I am reading this here. In this case, first data is read from the file n, first number, how many points you want to take. And then I start now do loop. So that now you see all the x values can be, each value will be x1 is just like x1 variable, x2 variable, x3, but this representation makes very easy for you for calculation and also for writing. So what is there that we have here? So we read under the do loop. So what will I read one by one? So first, let's say all these values are 0 initializing, and then read one data. So I becomes 1. So x1 and x corresponding y1 is read here. I have not put read n in the do loop because this has only one value. Then sum x was 0, so sum x is still 0, and then you add the first x. Similarly, sum y was still 0 earlier, so 0 plus then y1. And similarly, xy was also 0 because xy were 0, so x1 into y1. Then this is xi into xi or xi square. Then it repeats. Now this value is x1 summation, this is x2, and this is x1 and y1 and x2. And you are adding the new value because I takes 2 value. So you can see you can have summed all the values, and then like if you want to do by calculator, then you have to first write like calculate x1 is equal to this, x2 is equal to this, x3, and then make a program like, but do loop helps with the array content. That is why you see, very easily I could sum all the values and then apply in the formula written here. So I have got all the required xy sum, x sum ey, and sum x square. Now I will calculate x bar, y bar, and m values, and then finally write this. So what happens that, and then after this job is done, you can close the unit 10 where from you were reading. Now the rest part of the program is here. X bar is nothing but total sum x by divided by n, and similarly y bar divided by sum y divided by n, and m, as you can see, this formula is written. So here this formula written on the bottom. So that is done here. So everything is known, and then we can calculate C is equal to y bar minus m star x bar. You can print it on the terminal or write in a file. So that command you have to. So m is the slope, as you know, if you fit it the line, and intercept where this straight line cuts the y-axis. So that is the C value. Now you can check whether the fitting is correct or not. So what you can do here, you can see print x1, y1, and at the same time you obtain this from the straight line. You could write here something new value, but still you can write this way. So you can check the y value coming from the original one and what straight line will give you. So then you can see that the fitting program is done. So what we achieved here with the do loop and array, that the job has been done in a very easy manner. Now, so let's understand clearly. So like any other variable, arrays need to be declared at the start of a program. Unit and memory space assigned. Nowadays there is no problem. Like when we were doing calculation in our undergraduate, then we have to care that the computer were not available that high speed, high memory. So we have to see that whether we are choosing unnecessarily, you don't make it 1000 on both. So if you have only 10 data, then why to make 1000? But the advantage of taking high value for the dimension is that you don't have to change the program depending on data. So it should be a reasonable guess by you to put it. It's not going to use all of them. So it puts it in its memory x1, y1, x2, y2. So you can see all the variables are declared by this is the upper limit.
E-commerce.
So unlike scalar variable or array declaration require both type of integer and real complex. So like all the quantities can be declared, whether it is a real quantity
and there we go,
or integer quantity. So you have the choice declaring how. First,
the
you can
format statement.
Either real x
right,
and then give the dimension, like perhaps I did in this program. Real, no, here is the same. So the you could write real x, y and then give the dimension. Or you can do correctly, declaring as well as giving the dimension together. So that's a good thing to do. Like here, first I declare real and then declare dimension. So dimension is spelling you have to write dimension blank x10 and x100, y100. So you could use either this method, or you could write this method, or you could write this. All of them are valid, and declaration of the dimension can be done. Now, there is one thing, sometimes you are summing in a, for example, you are summing a log 1 plus x, or you are having e to the power x. So you think that you want to start, now this dimension, which is very important, you should remember it, which is I think many students
Also,
forget.
one should not write
This
keywords
dimension
and
has
names.
only 100 values.
Completely
That
ignore
has
it.
100 values starting from
Fred.
1. Remember, starting from 1. And sometimes you may have some summations are given where you want to sum from 0. So 0, 1, 2, 3, 4. So if you have to write 0 value, or sometimes there are negative subscript. So if you want to do this, then you better use the like this 0 colon 100. Now it will start with 0. If you have minus, so you can write minus 20 colon 100. So it will take the like many times you might have seen the subscript can be minus a, minus 2, minus 1 and 0. So if you want to accommodate 0, because I am warning you and repeating it many times, if you want to do this, then if you declare by 0 dimension, it is going to give you a problem. Like if you use x0, it's not until you have declared this in this form. Or so if you have not done this, then you can, or there is another way, like if you want to go from 1 to 100, then you can shift your summation. You can say the 0 is 1 and the 1 is 2 and 2 is 3 or so on. So that is how you have to be careful, because otherwise you miss one term in the series and the program will give you error and you will be puzzled why you are taking rightly from I0 to 15 and the program is not accepting. So I hope you remember this while we were running the program. Nobody should ask this question. Okay. Now, sometimes you don't know what is the maximum dimension you would like to give, because as I said, you have a data file and you don't know how many data are there. That's the one thing. Secondly, which is not nowadays, that you don't know whether what is the upper limit of dimension of the computer can take. Why I'm talking this? Because this is when you write 100, then computer reserves 100 allocation for you. So if you are not going to, that means unnecessarily reserving, like you are going in a hotel, you book 100 rooms and you require only 2, 3. So you have to pay the charges for 100. So here also, like if you unnecessarily give 100 and you don't know that whether you will require 100 or not, but you have to guess your upper limit. So the computer, but nowadays there is no problem. You can give 100, 200, it doesn't matter until you go 10 to the power 6 dimension or something. Because then as you will see that you are one had 10 to the power 6 dimension, y is also 10 to the power, then you multiply the quantity is going to make 10 to the power 12 cross quantities. So that is very high dimension. But you don't worry on this, just guess how many you want to do. Now this program, this page of the slide, this slide only tells you that in case you are not sure, then you can check and do this, read 10n, and if n is greater than 100, suppose, so you have to check, then it will say, okay, now your data is exceeding 100. Or the computer cannot take 100. So, but as I said, these are meaningless nowadays and don't worry about that. Okay. Until you have a very small computer, maybe you are working on your PC, which is still have large memory. There is another way then you can do that, you real allocate, mean declaring. So allocate means allocatable x and y. So you are not giving the dimension here as what, but you say just reserve x and y for the dimension. Then once you know this, then you can allocate x. Here is the same, like if you're not sure, then you can read n and check it. And after the job is done, deallocate it. There is another thing that people do is like if you are not sure, you can also give some number here, but always remember you have to use here some number, or you are doing the do looping. You can't write the dimension yes n. No, you cannot write that, because n has to be a number, because but when you go in subprogram, you can give n, define n, and then you say the dimension is there. So it works in that way. Okay, so now here you can read a quantity as was done earlier by using this, and or you could use another read statement in this way. This also, like if you have declared dimension, now let me also tell you that when you have declared a variable like x as a dimension, you can't use anymore this variable as a non-dimension. Don't think that, so this is now blocked by the computer that x has to be dimension. So then you cannot, sometimes a student asks, sir, I just declared x 100. If I'm not using y, it is, I can use x again as a non-dimension. No, you can't use it. The same symbol, or you can't use it. Like once I have declared x as dimension, I can't use, or once I had declared any quantity x as an integer, I can't use as a real variable. Or so declaration has meaning. Once you declare some quantity, then you are debarred from using it otherwise. Okay, so let's see. Now, there are some program which is mostly in MATLAB or the other places, and some of the computer may have. Like if you define any quantity simply by writing x, like here, if you have this dimension or here, and if you want like sum the x values, so you just write sum is equal to sum x, then it will give you the summation of all, because you have declared that. Then dimension should be correct. Like if you have 10 data, then only 10 can be. Then you can write sum x, you get the summation of the x, all the x values, x1, x2, and this thing. Similarly, you can make a product of the xy by writing sum x into sum y and this. So there are many computers nowadays that like you can write just like you write sine x, cos x, tan x in the computer, you could also write multiply the matrix. But I would suggest not to use these things, transpose of a matrix, because some computers may not have this facility, and like a MATLAB or something. So since you are using a Fortran, and Linux may not have this facility, so you are advised to rather make your program for matrix multiplication, transpose, and summation rather than this. Okay, there is another way that program we are making here. In this program, you see declare integer n, integer I. I'm using allocate. So real allocatable, then xy you can write. So now you don't have to declare by dimension, and rest other things in the same manner. So the program has, you read n and then write this. Here you are not, you see, because I have written in this way, so you don't have to worry about the dimension. And if you are using the data n, then it's fine. You can now allocate here. It says that these variables are allocatable. Now here you allocated it. So x1, and then now this is another way of writing the same do loop. Like here I have written this. So let me tell you, like if you write xi comma yi and then comma, remember it's comma, I vary from 1 to n. Then it takes the value I both places, x1 and y1, then I2 in both the places, I3. So instead of writing do loop, you could use it's a implied do loop that you can use also. So that's a simple way to read here. So like I am reading here by the same command. Otherwise, I have to put do loop there, do I equal to whatever, and then with the statement, and then do it. So it's an easy way to do this thing here. Now, then I calculate x bar, y bar, and sum x is also done here. Sum, you see here, once it is done, then I have used the built-in program of the computer SumX. So all the x values summed, sum y, all the summed values are y, and then sum x star y. So this sum function may not be available in some of the computer. So it's better you do the way I did. I did in the previous program, like you have to make the program sum here like this one here. You can see the lower part of the slide. So you have to sum accordingly, but if you, then there is no art basically, because the computer is doing and you are not making any program for that purpose. So, and then you can see, then you can just write down the things. Hello, yes? Any student wanted to say something? Okay. Now, then we are having here the all these are done in this program. Sorry, it's here. And then you print those things and see and deallocate, finish the allocation and just end the program. So you can see that this program is shorter than this, but I'm not sure that all the computer on which you will work have this built-in function. Like I can tell you, like some computer take SQT for square root as the same in. And like some British, British people have always to do things in what differently. So they don't want to do things like others do. So it's a quality of the British people. They do everything in a different way. So they write SQTF. So it's fine that we are not, they are not having so many computers made. So not to worry on that is, but when we were doing the calculation in undergraduate, then the ICL computer from UK has differently. So if you have written your program SQT, it will say SQTF as all. So anyway, now here is this data. The way you write it will look like this. You can see the last column, print 3, with the is the E10.3. So you see this, you can decorate this print already. So slope M, intercept C, you are printing, and then X, Y, and you can see this fitting is very nice. This is the original value. This is the original value, and this is the fitted value, and this is the original value. So all of them almost are. So it's very good fitting. We will discuss more of this in the numerical analysis portion. So, and this is the end data input file, and this is the output file here. Okay, let's see something more about this. Now, what is the advantage of using this is known as array, like X is array quantity. So now array has very good, it's had a lot of advantage also, like if you have to transfer some quantity from main program to the other subprograms, which we will discuss next lecture, that you can just like you transfer it, just write X and transfer it. So that's fine. All the X100 values, X1 to 100 values will be transferred to the program. So that's what, if you write A is equal to 2 and declared this as an array quantity, then all the quantities will be, all the A1, A2, A3, A4, 5 will be equal to 2. And similarly, you declare B is equal to something. So if A, B, C are the declared dimension quantity, then you can simply write, you can sum the two matrix, column matrix basically, because we have used only one quantity. So you can have separate statements like for this. For example, if you have A1 is 2, A2 is 4, A3 is 6, A4. So you can write do AI is equal to 2 star I. So I changes 1 to 5. So you can see it can give you all the values over here. That's the one way you can initialize the data. Like if you know that they change by this, so you could use simply this formula. There is another way, a data statement, where normally this data blank, then X1, X2, or A comma B comma C, or P comma Q. So you have to write A comma B comma C, so you can write ABC quantities. But if it's a dimension, is declared 10 dimension, or like your, so it will like if you have declared A as a 10, so and give here only write A and then give values. So up to 5 storage will be given. A1 will be given 2, A2 will be given 4, A6, A3 will be 6, and so on. So dimension can be higher, and here it knows expect values if it is declared 100, but it can put whatever value you give. Rest are still vacant, those values. So that's the one way you could write data statement also. So how to initialize array, how to fix the value of, or you, then there is another way, like you could write A equal to this. Now, when I say you write this or this, then not all the statements are valid in all computers, but this data is good enough. It's in every computer the same. Like if you write A and then slash here. Now here, remember, you have to give here 2 slashes and the variable created by, then it starts from 1 and memorizes this value. Or you could write, if you see something common like 2, you could write data and 2 star I, like is done here. Okay, so this is how there you can initialize the dimension or array quantities. Now, array quantities can also be, written in the form of assignment. So that's the same thing. If you write X is 5, then all the values are given. You declare this here on the top that they can take 10 storage each, and then X5. So all the values will be given the same value. Then you write -3. So Y1 will be equal to 3 times X1, which is 5. And so this is the also you can find out the sin X value for different values of X size, and their Y values are there. So this is also, instead of writing sin Xi or Yi, you could write this. Now, I talked up to here only one dimension that but in matrix, you do not only have one variable. You have like if we go on the row, first row, so A11, A12, AN3, and A1N. And similarly, if you go column wise, then this will be A1, 2, A21, A31, AM1. So far I have discussed if it has a one value. Now you can also declare the same. A can be declared to have double dimension. So it's a two-dimensional quantity. So like here we are writing, now there are two variables here. So the quantity, like if I write A33, that means the first variable has up 3 maximum dimension, second also has maximum 3. So you could write with using only A33, you can feed all the 3 by 3 square matrix element in this. So you see great advantage here. So how will you understand this? Like A11 will be the first and element of the first row, then second element of the first row, and these values. So it's exactly the same. And so if you want to understand, you simply can understand that it is A11 is like this feeling, but you are given a quantity. So that makes this quantity. Now you see, I have written like you can give like this also, but you could, if there are more values, so you can easily use do loop and do this thing. So for example, here there are two matrices written here. A is 1, 2, 3, 4, 5, 6, and 7, 8, 9, and B's. Now you are, how will you read this matrix? So as I said, there are three ways to read this matrix. How? First, you can adopt read. Of course, if you know which file, otherwise from the, from your monitor, when you type, you give it. So it says 21. 21 is the format accordingly. And then you write Aij. How do loop will work? I is first value. Then it comes here. Then j is taken one value. Then this do loop completes. So it will be A1, 1, A12, A13, and so after this completes, and then it goes out here, and then what will be then this do loop ends. Then again it will take 2, and then all j will take all the values 2, 1, 2. So you can say all the rows can be read by using this. So only 4 statements can give you to read such. Otherwise you have to write, if you want to write, you will write A1 like here in this slide, give like this. So it's fine if there are 3, 4 values you can write down, or you could write A1 is equal to 1.0, then next line A12 is equal to 2, A13 is, then you write A21, A23. So give all those values, 9 values on the screen or on a single statement and do it. Now another way do it, you use the do loop only for the first variable. So I is 1, so 1 is fixed, then all the j values can be read. So that's also, so here we have do loop and implied do loop work together. Or you could use this statement where all the values can be read by a single statement. So here you see some statements have reduced, only one do loop is used here, and rest with the implied do loop. So, and this here we have both. So first it fixes the first variable I, you see, that's why a bracket is used, that first take I and then vary all the, so here I will be 1 and all the j values will be summed So you have to, when you write this thing, be careful that how otherwise you will mix the rows and column and get a wrong answer. So here you have to see carefully that how it is done. First, what happens? So and then so these are all equivalent. So either use this way. Up to here it's clear, there is no problem. Up to here it's also clear that, but here you see, you have to see that the bracket is used. Bracket is used means first it will be done. And same thing you do with the other matrix B. So now you have read both the matrices, and then let us see what we want to do. Now let us say we want to multiply, matrix multiplication. So these matrices are read, and now you could use simply, dimensions are declared. Of course, you have to declare the dimension here, and you could use this statement. But as I said, I'm not sure that this type of summation or multiplication is available in all the computers. So I would better make a program for sum, or the like you could write this. Now, so you will see in the next slides that how I can sum or multiply two matrices myself, how to make a program. So let's see, after we have read those matrices, so real dimension, real quantities are ABCD, they have both 3, 3, so it's a 3 by 3 matrix. I want to multiply, like if a matrix says of the order A or I cross J and J cross K, then you get I cross K matrix. So since it's a square matrix, if it is not a square matrix, then also you can do this job. Anyway, so let's see, it doesn't matter, it's a general one. So like read 8, and all the matrices are here read. So that means I use this first here, which is written second choice. So second choice I have used, one is do loop and rest implied do loop, and do, and or, and I have also used the third choice and read this. If you are using built-in program of multiplication, you could write C is matmul AB, and then after you have got this, you have got the matrix multiplication, you have got also the summation of the two matrices, then you can write. And now write statement can also be done with the do loop or implied do loop. So like here, write 9 matrix A is, so you can write this matrix. So I have used implied do loop. So always read and write so that you know that the matrix you have the way you want to be read, it has read that way. So matrix B is here, so you can write matrix C is also can be written, and also this sum. So you can see that here I have summed the two matrices, which otherwise could be done by this two formula. Now this is, as I said, I'm not sure that all the computers have, and even the computers have, since it's a programming course, so you better do yourself. How do I multiply? So summation is not a big problem, but how do I multiply a matrix? That I'm asking you to do. So first thing what we have to do, I have to have two files. First I declare the dimension of this quantity, easy way. And then I want to, I can use IJK element, so no declaration is required in most of the computer. Since I need another variable P, which should be integer, so I declared it. Now I have named these two files where I'm reading the order of all the three matrices. Two matrices are given, and the form matrix is also, we know that what would be this matrix. So I am using two do loops and straightway reading and writing to check it that now this way if I read, then you know all the matrices are written in a single column. So first it will read Aij here. So you can see that this way of reading will give you all this. So make some arrangement so that A matrices are written row wise and column wise. Now here it will straight will write all the elements in a straight one column here. So then now what I'm doing that I am reading again the B matrix. Which is one matrix is m by n, another matrix is n by p. Now these can be multiplied because n is the common here. So the resultant matrix will be I cross b or I by p. So after we have done, now I am finding, I know that I goes from 1 and k 1 to p. So first I make, if you remember how to multiply matrix, so what you do that you multiply the matrix here and make a sum there and then store it. So like all the rows will be multiplied by the each element of the column wise, and you know that the matrix can be summed in this way. So first I make the I is first chosen and k is then chosen here and then summed over the j. So, and then I store in a matrix I by k as a sum. And then I continue. So each element, the way I'm telling, is stored here. And finally, I print Zik using this. So this is the way I can multiply two matrices, and the third matrix form will be the same thing. Now, if I ask you through a computer, make a matrix multiplication A by B and also by C, and the resultant matrix will be, so far I told you A and B gives you the multiplication matrix C, but I say that A and B will give you C and C will give you the D. So multiply AB and B to C, and then at the end the three matrix to multiply. Then how will you make a program? So first you read all of them, three matrices which are given. Okay. And then you multiply these. Now this is in fact an exercise that how will you multiply this three matrix. So I first read all of them and then do it by first I multiply AB and make a matrix R. And then I multiply R matrix by C matrix. So AB multiply and make a matrix R the way I told you, and then multiply this R with the C matrix and get the result D matrix. So it's the first part of reading. It's the second part of doing this. So first multiply AB, get R matrix, and R multiplied by C, get a D matrix. That is how three matrices can be. And now these are the different ways, like I could simultaneously multiply all the three matrices. So that is what I have shown here in this program. So alternative second part can be written in this way on the red, with the red. So maybe you can look at it and see that. And similarly, further second part you could write. So there are a lot of choice that you can use. And if I were you, I will make a program in which I will multiply all of them together in a program rather than doing that. So that requires expertise in the computer. That is what you have to learn. Okay, so today I stop here. And if you have any question, you can ask me. Students? Hello?
So I had a question.
Yeah, tell.
Like if we use two do loops and we also can use implied do loop.
Mm-hmm.
So which one should we prefer?
Yeah, implied do loop is better because it is, if you take two do loops, they are equivalent. So then you have to type, four, as I said, four statements. And if it is implied do loop, you don't have to do four statement. As I told you in the beginning, the best programmer is that programmer that makes the program with a least number of statements. That means you are utilizing your skill and then doing it. So that is what, like I make a program and then A is equal to this, B is equal to this, C is equal to this, and they make like a calculator and give you. So many students, in spite of telling them that they will write A11 is equal to 2, A12 is equal to 3, and then rather than smartly using do loop and read the input. So that is what is here. Like implied do loop is preferred always. But if you are not comfortable, you can use, in implied do loop, you have to see how you are, making these entangled, the two variables. So you have to better check it by printing that what you want, rather than mixing up I and j variable. You can see that the way you want. The mixing can be like if you are thinking you are wearing like a row wise reading your data is while you are reading column wise. So that